Now going ahead with the chapter probability, which is we are going to solve the exercise 14.1 questions. And the first question is about the fill up the blanks. There are a certain number of fill up the blanks given. Let's have a look at it and let's do the first one. This first one states that what is the probability of an event occurring plus the event not occurring. Okay, so that means we have done this particular formula. The probability of the event occurring plus the probability of the event not occurring can be taken is always 1, is what we already know. Okay, and the moving ahead, the next one talks about, this is A, and then the B one is there, which talks about the question as the probability of an event that cannot happen. So here it says that the event cannot happen. So when we are talking about not happening, so what is it going to be? When it is not happening, that means it is not possible. It is an impossible event. What will it be called as? It will be called as impossible event, it is called as. And apart from that, its probability of an event which is not possible, it's going to be 0, is what we understand in here. The next one is given as the probability of an event that is certain to happen. Certain to happen means compulsorily it is going to happen. Okay, what is that probability going to be? The probability is going to be, probability of the event is going to be 1. Certainly it's happening tomorrow, so it is going to be 1. Okay, and such events are called as surely likely events. Okay, surely likely events, or sure events is what we are going to call them. Moving ahead with the next one, that is given as the sum of all probabilities is equal to what? The sum of all probabilities, we know sum of all probabilities, it is going to be equal to 1. Okay, probability of all events, that is, this is called as sigma. Okay, and its meaning is summation. What is it? It talks about summing all of them, so it is equal to 1 is what we know. Okay, the last one that is given is the probability of an event is greater than, okay, the probability of an event is, this is greater than or equal to 0. Okay, it is never going to be, it is the maximum it can be is 0, the minimum it can be is 0, and the maximum it can be is 1. So the probabilities are going to be between 0 and 1, nothing beyond 1 and nothing less than 0 is what we are going to have. Negative probabilities we don't have any time at all. Okay, moving to the next question. Moving to the next question, it is talking about the equally likely events. So when they are talking about equally likely events, that means there is the equal probability. Okay, so the equal probability, and when you find the answers of each of the conditions, the answers will be same for them. So now the question that is given is the first one. If a driver attempts to start a car, what is the probability? Is it going to be equally likely event if it is starting or it is not starting? So if you do not know what kind of a car it is, isn't it? There is a car that we have, and I am going to start a car, normal car. If it is a new car, car in use and all, we know it. Then we can say that, you know, there are two possible options. The car is going to start or it is going to not start. Okay, either of them will be there. Okay, but if the car is very old, okay, if the car is very old, so we do not know if the car is old or how is the car, right? So what we are going to do, if the car is old, there is only one probability, it will never start, isn't it? The car is broken, it is not going to start. So in this particular condition, the car is not defined. What is it? A new car, the car is already in use, and the car is old, nothing is given to you. So we cannot decide if the event is equally likely or not. So it is, we are going to say that it is not equally likely. Okay, likely is what I'm going to mention in here, because I cannot decide it. The further next one that is there is shoots a basketball. Now when I talk about shooting a basketball, what is it? It is that, you know, now how, again, we do not know if the person is if the person is how many total shoots the person is taking. Okay, it's just talking about a player attempts to shoot a basketball. How many times he is attempting, again, we are not given. So the total number of times is not given to us. It is just randomly asking us that if it is going to be, what will be the probability. So I cannot decide the probability of an event when the total number of shoots or attempts are not given to me. Okay, the next thing that we have is, now again we can say that it is not likely possible for us to decide, so it is not an equally likely event. Okay, it is not an equally likely event, because the amount of shoots he's trying to attempt or he's trying to do is not given to us. Okay, then the next question that we have is the trial is being answered in a whether the event is true or false. Yes, when we know that we are talking about a trial, there are only possibility is that the answer is either going to be true or it is going to be false, and he cannot make up any other story because he's just supposed to answer true or false, whether it is right or wrong. So true or false are the two only options that I have. So what will be the probability of true? It is going to be 1 upon 2 because the total number of outcomes I know. Okay, here also false will be 1 by 2. So this is an equally likely event. Okay. Okay, moving ahead, we have the last question, which is if a baby is born, what is the gender of the baby going to be? The gender of the baby, we only know that the total possible outcomes are either it is going to be a boy or a girl, right? So here what we are going to do is the probability of boy is 1 upon 2 and the probability of being a girl is this. So it is also an equally likely event, is what I understand. I fail at writing those big sentences in here. Okay, so that's pretty much it of the second question. Further going ahead, the question number 3 is an explanatory question that they will not ask you to do. This kind of question, this was also an explanatory question, the question number 2, but to make you understand like why are these considered to be equally likely events and why they are not considered to be equally likely events, that's why I did that particular question for you. Okay, now moving ahead with the next question, it says that which are not the probabilities of an event. So which means what is the probability of an event? The range for probability of an event is it is greater than or equal to 0. Okay, it is greater than or equal to 0 and it is less than or equal to 1 is the probability that we know in here, isn't it? So it is going to range between 0 to 1. We already are aware of it. Okay, now here it says which are not the probabilities of an event. So let's see, negative 1 by 2, 1.5 will not be, because this is an option, because negative probability cannot exist for the fact that it is a negative number. The probabilities go from 0 to 1. Okay, these are the things that we have. 15%, so 15 upon 100, that becomes as 0.15 will come in here. 0.7 always obviously lies in this particular range. Then we have 2 upon 3. So when I'm dividing 2 with 3, that goes as 0.0, and 6, 18, and then 2, 6, 6 is coming. It is also a decimal number that is between the range of 0 to 1. So all of them are the probabilities, but this is the only one which is not the probability of the event. Okay. Going ahead with the 5th question, it says that the probability of the event is equal to 0. The probability is given actually. If the probability of an event occurring is 0.05 and the what is the probability of the event not occurring? So we are aware of this particular theory, probability of the event plus the probability of the event not occurring is equal to 1. So event occurring is given as 0.05 to us plus the probability of the event not occurring will be 1. So when I send it towards the other side, this is going to be 1 mark questions. Okay, so when I send it towards the other side, it becomes 1 minus 0.05, that is equal to 0.95 will be the probability that will be there for this one. Okay, so the probability of event not occurring is equal to this. Okay, going ahead with the 6th question, it says that there is a bag that contains the lemon flavored candies. Okay, and Malini is going to pick out from that bag without seeing, and so what is the probability that she is going to get an orange flavored candies? But if you look at the condition in here, the bag contains only the lemon flavored candies. There is nothing inside it, isn't it? So this is an impossible event. She can never pick out a a orange flavored candy here. So the probability of the event for this one is going to be 0. Okay, likewise with the lemon flavored, what is the probability that she picks out a lemon flavored candy is what they are asking. So when I have to pick out the lemon flavored candy, then in that scenario, how many are there lemon flavored candies? It is surely she is going to pick out a lemon flavored candy, isn't it? It is because the bag only contains lemon flavored candies and she will pick that out. So the probability of the event is 1 here. It is a surely likely event. Okay, surely likely event is what it is. Now people will say how if suppose there are 10 lemon flavored candies, so when she puts in the hand, the probabilities of all favorable outcomes upon total outcomes, right? So the favorable outcomes are this and divided by the total number of outcomes, that is the total number of outcomes are also 10. So 10 and 10, it becomes 1. That's how we know it. Okay, now going ahead with the next question, it says that the group of 3 students are there. Probability of 2 students not having the same birthday is this. Okay, what is the probability of the two students having the same birthday? Now in this particular question he is mentioned group of 3 students. The probability of 2 students not having the same birthday is 0.992 is given to us. What is the probability of 2 students not having the same birthday? Now for this question, he has actually confused us all, okay? The group of 3 students he's saying, but the probability of 2 students only he's asking. So the probability of the 2 students having the birthday on the same day is given to us as 0.992. Then what will be the probability that these 2 students do not have the birthday, okay? Sorry, not having the same birthday is 0.992. What is the probability that they will have on the same day? So it's like one of it is in favor, the other one is not in the favor. So now not having the same different birthdays is what they are asking about, okay? Not having the same birthday is given to us. Having the same birthday is asked. So it is going to be the probability of the event plus the probability of the event not occurring is equal to 1. Here the not actually is given to us because they are not having the same birthday. So probability of the same birthday plus 0.992 is equal to 1. So when I send it towards the other side, the probability that they have the same birthday is going to be 1 minus 0.992, which will turn out to be 1 minus, it will become 1 minus 0.992. Okay, so it becomes 10, 9, 10, 9 and 10, 800, 0 point. So it is going to be 0.008 is what you get, is the probability that they both have the same birthdays. Okay, now moving ahead to the next question, it says that there's a bag that contains 3 red and 5 black balls. Find the probability of red and not red balls. Okay, so the probability of finding the red balls is probability of the event is equal to red balls. How many are there? There are 3 upon the total, isn't it? Because the formula is favorable events divided by the total events, total outcomes, sorry. So 3 plus 5 is what I have here. That becomes 3 plus 8 is what I have. Then it says find the probability of not the red. Not red means this is for red, not red would be the same. Probability of the event, the probability of the not event is equal to 1. If this is 3 by 8 plus not is being asked and I towards the other side, probability of the event not occurring is equal to 1 minus 3 upon 8 is what I have here. So that becomes 8 minus 3 upon 8 is what we get, which is 5 upon 8. Okay, this is by using the formula. If I'm not using the formula directly, I want to do it. Not red means he's skipping the red, it is only about the black ones. So probability of blacks would be, black balls taken out would be 5 upon the total again. So 5 upon the total is 8 in here. So both ways you get the same answer is what we learned. Starting with the 9th question in here, it says that there is a box that contains 5 red, 8 white and 4 green marbles in it, okay? One marble is picked at random. The probability, this is the gist of the question that is given. I have not taken down the question as it is from the textbook because it would have become too long for me. So the box contains 5 red, 8 white and 4 green marbles. One marble is picked, okay, from this particular bag. What is the probability of the red marble? So probability of the event is equal to, for the red one when we are doing it, it becomes red means how many are red, favorable about the total, that is 5 upon total is going to be 5 plus 8 plus 4, that turns out to be 5 plus 9, 9 plus 8, 8, 6, 17. 5 upon 18 would be the first one. The second one is given to me as what is the probability of the white. So probability of the event is equal to favorable upon the total. What is the favorable one? The white one is here. So 8 are the white ones in here and the total is given as 17. Okay, moving to the next one, it says that what is the probability of not getting a green one? Okay, so when we talk about not a green, so that means we should not get not a green. So other 2 colors except green, other 2 colors have to be taken up. So the probability of the third event is going to be red plus white, favorable upon total, and here the favorable ones are not green. So not greens are 5 and 8 in here, and at the bottom again total outcomes are 17, so that is going to remain in here. That becomes as 13 upon 17 would be the answer in here. Moving ahead to the next question, it says that the piggy bank has 100. There is a piggy bank. In that there are 150 paisa coins. So 50 paisa coins like this. There are 100 coins in here. Okay, 51 rupee coins. 51 rupee coins are there like this. 50 are there. 22 rupee coins are there, and 10 5 rupee coins are there. The probability of they are all present in coins. If you see, what is the probability of getting a 50 paisa coin? So the probability of the event is equal to, for 50 paisa, how many are there? 100. It is favorable upon 100, so it is 150. 100 are there in here. Sorry, total coins are there. Sorry, favorable upon total. So how many total coins that I have of 50 paisa? It is 100 coins. So it goes 100 upon the total number of coins is 100 plus 50 plus 20 plus 10. That turns out to be 100 upon 150, 160, 70, 180, 180. The 0 goes off. If you can further reduce it down. 2 5s and 9s, so it becomes 5 upon 9. You can leave the answer like this, or you can take it in decimal also. Most of the times I've never taken it in decimal. You can leave your answer in fractions as well. Okay, for the second question, it says that will not be a rupee 5 coin. So it should not be a rupee 5 coin. So I should hide all of this. Rest everything I have to take into consideration. So the probability of the event is equal to favorable upon the total. We know it is 180 now. Now from that 180, 5 rupee coins have to be removed, only the 5 rupee coins. So 10 coins have to be removed from the total. The total number of coins including all of this is 180. From that 10 coins you remove, so 170 upon 180 it becomes. So 0 gets cancelled. We get 17 upon 18 here. Okay, now going ahead with the next question, it says that Gopi buys fish. Okay, and she goes to a shop and to buy the fishes. So what's going to happen is there's a shopkeeper. Now from the fish tank, the shopkeeper is taking out one fish, and in the tank there are 5 male fishes are there, and there are 8 female fishes in here. Okay, so what's given over here is the probability of the fish taken out is a male fish. He picks out one. The shopkeeper picks out one and puts it in the bag to sell it. Okay, to Gopi. So what is the probability of the event over here? The probability of the event is we are looking forward for male fishes. So it is going to be 5 upon the total number of fishes, which is 5 plus 8. So it becomes 5 upon 13 would be the answer for this one. Okay, moving ahead with the next question. It says that there is a game happening, game of chance, spinning an arrow on a plate. There's a plate. If you look at the question in the textbook, there's a plate and there are certain numbers given onto that particular plate. Okay, so it has been divided into 8 sections. I think these are the 4 sections, and then you have something like that. It is divided and 8 sections are there, and numbers are given also. So 1 2 3 4 5 6 7 8 are there, and you're going to spin it, and wherever the arrow points, you're going to be winning that particular thing. So this is an equally likely event. That means each of them are going to have the same possibility of coming. Okay, the number coming onto the arrow. Then it is asking what is the probability that it points at 8, because all of them are there. Nothing is repeating in here. So the probability of getting an 8 is equal to, or the probability of the event is equal to, how many 8s do I have? I have 1 8 divided by the total outcomes that I have. Total outcomes is 8. Finished. The second one is, what if it is an odd number? So the probability of the event is an odd number. So how many odd numbers do I have? 1 2 3 4. So it is going to be 4 upon 8. Total outcomes, right? 4 upon 8, that becomes 1 by 2. Okay, the third one they are talking about is number greater than 2. Okay, so number which is greater than 2. Greater than 2 means always greater than 2. Equal to 2, no. Above 2. So the probability of the event for this is going to be 1 2 3 4 5 6. So it is 6 upon 8. So reduce it down, it becomes 3 upon 4. So 3 upon 4 is what we get here. Next is a number less than 9. So how many numbers are there which is less than 9? All these numbers that are given over here are less than 9, isn't it? So the fourth one goes as, the probability of this event is going to be 8 upon 8. So all the possible ones will come in here. So it becomes 1 when I reduce it down. Okay. Moving ahead to the next question, it states that die is thrown and find the probability that, die means the regular dice that you have that is being thrown, and this particular dice what are the total outcomes? Because usually when they say that the dice is thrown, we do not know what are the outcomes. So let me just write down the outcomes in here. 1, 2, 3, 4, 5, 6. These are the outcomes that I have. Now they are asking what is the probability that it is a prime number. So how many prime numbers do I have? I have 1, 2, 3, 5. 3 prime numbers is what I have here. So the prime numbers, so probability of the event is equal to 1, 2, 3. 3 upon total outcomes are 6, which is 1 by 2. Okay. The second question that is asked is number between 2 and 6. So the probability of the second event is numbers between, he's asking. So 1, 2, 3 numbers I have. 3 upon the total outcomes are 6. So it is also 1 by 2 is what I will get in here for this one. Okay. Further ahead with the next question that I have. The next question that I have is the 14th question given over here. There is a deck of 52 well shuffled cards in here. When a deck of well shuffled cards is there, you are quickly, if some students who cannot remember it, I would suggest you to write down the cards. You have 52 cards, block it down into 26 and 26. Okay, this is going to be red and this is going to be black. Okay, and then you are going to black it down into spades, 13 spades and 13 clubs, and 13 hearts and 13 diamonds is what you have. Okay, then in this you have the columns of ace. Okay, what do you have? You have an ace, you have a numbers 2 to 10 you have, and then you have king, queen and jack. Okay, this is a set of 13. Now he's asking me deck of cards is there 52, and you're going to pick out a card such, and you have to find the probability of picking out a king of red color. So how many kings do you have in red color? In red color, I did wrong here, look, red is, this is black actually, black is spades and clubs, red is hearts and diamonds. Okay, so he's talking about the king of red color. So in red color he's talking, you will get a king here and you will get a king here. So how many kings do you have? You have 2 kings. So first one, the probability of getting 2 kings is equal to, you can write like this also, probability of getting king of red color is equal to, you can write like this also, how many do I have in red color? 2 kings are there, divided by total number of kings cards. So total number of cards is 52. So 52, reduce it down, 2 ones are 2 twos are, and 6 are 26. So 1 upon 26 is what you get. Okay, now the second one that is given is, it says it is a face card. Face card means the king, queen and jack. This is going to be there in one set, king, queen and jack, one set in this, one set in this, one set in this, one set in this. So 3 into 4, total of 12 cards are there for the face cards. So the probability of the face cards is 12 upon 52. Reduce it down further again. Okay, some students who cannot do it, I would suggest go with dividing with 2 table. Some students will not remember the 12 times table. Some ones who remember the 12 times table, they can do it very easily. Those who cannot, either go with 4 table or 2 table, as and how you can go. So 2 6 it will go, 2 2s and 6. Then again further, can you reduce it? Yes, you can reduce it. 2 3s it will go. Okay, and 2 1s it will go, 13s. So 3 upon 13 is what you get for this one. The next is the red face cards. Okay, so the probability of the third one is, of the event is red. In red, how many do you have face cards? I have 3 face cards in hearts, 3 face cards in diamonds. So it is 6. So it is 6 upon 52 is what you get. Okay, 6 upon 52 is going to be how much? 6 times 2 table again, 2 3s it will go, 6 it will go, 26. Okay, 3 upon 26 you will get. Going with the fourth one in here, it says it is a jack of hearts. How many jacks do you have in hearts? So this is the hearts column. How many jacks do you have? I have only 1 jack in here. So it is going to be, probability of the event is going to be 1 heart out of the 52 cards is what I have. The fifth one is the probability of the event is for finding the spades. How many spades do I have? I have 13 spades. So it goes as 13 upon 52. That goes as 1 upon 4 will be the, when I reduce it with times table of 13, it goes as 1 upon 4. The last one that we have is the queen of diamonds. How many queens do you have in diamonds? You have only 1 queen. So the probability of that event is going to be 1 upon 52. This is how you do the question. Okay, moving ahead to the 15th question, it says that 5 cards. Now the listing of the cards is given. It's not the cards from the deck of cards that is given. It says 5 cards, the 10, Jack, queen, and king and ace of diamonds are placed in here. Like all of them have equally likely probability. What is the probability if I pick out a card that the card is a queen? So the first question is asking about the card, okay? So we do not have the deck of 52 cards, but we have certain cards selected from the card, from the deck, and that is 5 cards, 10, Jack, queen, king, and ace of diamonds. These all belong to the diamonds, okay? So what is the probability that the card is a queen? So for the probability of the queen, for probability of the event, how many queens do I have from this set of cards? I have only one queen. And what are the total number of cards that I have? I have 5 cards in here, so it is 1 by 5. Okay, the second question that is asked is queen drawn. What is the probability? Queen is drawn and put aside. Now this kind of a condition is called as, is where the second draw, usually what is actually happening is I have the 5 cards in here. Okay, I pick out one card and I see, okay, the queen I have picked out. Luckily this was the queen, it has come out and I've kept it aside. I am not going to put it back in here. Usually in probability, you pick it out from a bag and then you pick it out and then you put it back into the card, into the bag. It is how it usually done in probability. But in this particular, but there are certain conditions wherein you pick it out and you keep it aside over here. You do not put it back. So this is the same condition that's happening over here. You took out one card and that was luckily to be a queen. You have put it aside. Now you are left with only 4 cards in here. Okay, the second card is ace. In the second question there are 2 conditions. The second card is either it is going to be an ace or will that be a queen. So the second question, part A, I in the beginning I had 5. I have taken that one queen out. Left with me are 4 cards. So the probability of the event is going to be favorable upon total. Now I have only 4 cards in my hand because the queen has already gone out. 10, Jack, king, and ace are there, okay? So he is asking me what is the probability that it is going to be an ace. So the probability of ace is only 1. So it is 1 upon 4 is what I get for this one, okay? The next is, what is the probability that the second card drawn is going to be a queen? So when the second card is drawn out, the probability is impossible over here because the favorable, there are 4 total outcomes. What are the outcomes? 10, Jack, queen has been gone out already in this particular first draw. King and ace are there. So is there any more queens that I have? I do not have anyone. So it is going to be 0. It is an impossible event is what we understand, okay? The further ahead, we have questions like 12. There is a bag in which 12 defective pens have got mixed up with 132 good pens. Okay, so they were good pens and there were 12 defective pens, but somehow they got mixed up. One is picked at random and find the probability that the picked out pen is a good pen. Okay, so what is it? The probability, first of all, let's do the total in here. Total is equal to 132 good pens plus the 12, what do I have? 12 defective pens is what I have. Okay, 12 defective pens is what I have. The total pens will be 4, 4 and 1 is what I get. Okay, these are the total number of pens that I have in here. Okay, then it says that probability that it is a good pen. So the probability of the event is equal to favorable upon total. So the favorable one is 132. 132 divided by 144, isn't it? Is what I get. Now I need to reduce it down. When I reduce it down, it goes as 2 6s are 12 and then 1 will be left, 6 are, and this goes as 2 7s are 14, 7s are 14 and 2s are. So it is 66 upon 72 is what I get. Then times 2 table, 33, 3 and 6. They both come in 3 times table, 11 and 12. So the probability is 11 upon 12. You have to reduce it down to this and write it down. If you cannot write down the decimal, if you can write down the decimal, you're allowed to write down the decimal as well. Okay, now another question is given over here which says that 20 bulbs contain 4 defective ones. Okay, there's a bag of bulbs, out of which 20 bulbs are there total, of which there are 4 defective ones. Okay, I got confused with my question, with the question that I wrote. I had to go back and check the question. So it says that there's a lot of bulbs. Okay, a lot of bulbs means a bulk of a good number of bulbs have been put in there. Okay, a lot of 20 bulbs are there actually in there. Okay, so there is a lot which contains 20 bulbs in here, and that 20 bulbs contain 4 defective ones. Okay, it has 4 defective ones. Now you're going to pick out one bulb at random. What is the probability of picking out the defective bulb? So for the first one, it's going to be probability of the event is equal to total upon favorable. So it is total is 20 and favorable is, it is talking about the defective bulb. So how many do I have? I have 4 defective bulbs. Okay, that is becoming 1 upon 5 is the probability. I understand. The next one, it says what is the probability that the next bulb drawn not defective and is not replaced. Okay, so the next question that they are talking about is that, suppose the bulb that I have picked out in the question 1, that bulb happened to be non-defective. Okay, it's actually a non-defective bulb, but in the question it is talking about a defective bulb that I have picked out in the first place. Okay, so I picked out a bulb for the defective one. This is the probability, but for the second one, supposedly he's saying that when you are picking out this first one itself, it turns out to be a non-defective bulb. Okay, it is not defective and it is not replaced. Okay, so what's going to happen in here? First of all, I have in the first beginning when I'm picking out, total number of bulbs are 20. Okay, 20 minus 1 because one of the bulbs has been taken out. So probability of the event is going to be not defective. That means the good bulbs has been taken out. So how many good bulbs are there actually? 20 are the total bulbs. Okay, minus the 4 defective, isn't it? So that becomes 16 good bulbs is what I have. Okay, from this 16, in the first pick, what I'm doing is I'm picking out one bulb out of it. So now how many am I left with? I'm left with 15 good bulbs. Okay, 15 good bulbs I'm left with. And then how many is the total number of bulbs? Because he said not replaced. That means it is just picked out and not put back. Okay, so it is that the total number of bulbs also from 20 it has now gone to 19 only. 19 is the total number of bulbs that I have. So the probability is the event of favorable upon total. Okay, so how many is he asking? Pick out one bulb such that it is a non-defective bulb. Again he is asking about a non-defective one. So how many do I have non-defective? It is 15 non-defective, but the total number is reduced to 19 because it was not replaced. Okay, the next question onwards, it says that there is a box that contains 90 discs which are numbered from 1 to 90. Find the probability of the one disc that is picked out is going to have a 2-digit number. Okay, fine. First, the probability of the event is supposed to find out that it should be a 2-digit number. Okay, so 1 to 9 are 1-digit numbers, isn't it? These are 1-digit numbers that I know already. So from 90, if I subtract these first 9, then I will get the probability or not. So 90 minus 9 is equal to 81 is what I get. So the probability of the event is equal to 81 upon total is 90. Okay, because right from 10 onwards, there are 2-digit numbers itself. Okay, the second one that is given is find the probability that it is going to be a perfect square number. How many perfect squares do I have? I have from 1, 2 square is 4, 3 square is 9, okay, 4 square is 16, 25, 36, 49, okay. So each number has its own perfect square, isn't it? 1, 4, 9, 16. So 9 numbers up till 99 is coming in here, okay. 90 digits are there, right? So 49 is there, 7 7s are 49, 8 8s are 64, 9 9s are 82, 72, 81 I guess. 9 9s are 81. Okay, I am so weak at tables. 9 10s are 90, yeah, 81. Okay, so 9 10s are 90, but that's not a perfect square. So how many do I have here? The probability of the event is the total numbers are 90 divided by the favorable ones 1 2 3 4 5 6 7 8 9. So it is 9 upon 90, which becomes 1 upon 10. Okay, now further ahead, some students are intelligent enough to just write it down like this would be the possible thing, but some who cannot, that's why I've written down here. Next one, number divisible by 5. What are the numbers divisible by 5? That ones that end in 5 and the ones that end in 0. So everywhere you have in from 1 to 10, you have two numbers. Likewise, from 10 to 20, you have again two numbers, isn't it? 15 and 20 will come. So in each set of 10, 10, 10, you have two. So 90 sets you have like that. So in 90 sets you have no 1 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. So likewise, you have nine sets. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sets you have. In each set, I said there are 2. So 9 times of 2 is the number of divisible by 2. Okay. So which one are those? They are 5 or 10. They are 15 or 20. They are 25 and 30. Like that. So it is 18 total. So the probability of the event is equal to 18. Numbers are divisible by 5. And then the 90 is the total thing. So it goes with 9 times table. 9 2s it goes, 9 10s it goes, and then 2 1s it goes, and 5s. So it is 1 upon 5 is the value that I get. Going to the 19th question, it says that, okay, now going ahead with the 19th question, it says that there is A, B, C, D, E, A. These are the there's a dice which has like usually the dice that we have is 1 2 3 4 5 6, but this dice has A, B, C, D, E, A. Okay, now this dice has been thrown, and what is the probability of getting an A? So the probability of getting an A, the first option is, how many A's do I have? 1, 2. So it is 2 upon 6, which is 1 upon 3 would be the probability. The second one is, what is the probability of getting a D? Probability of the event is equal to D, D is 1, 1 upon 6 is what you get for this one. Finished, simple question. The next one is, there are 144 pens in a lot or something. 20 pens are defective. Okay, out of this 144, 20 pens are defective. Noori buys a pen if it's good, but will not buy if it's not good. So defective pen she's not going to buy. Good pens she's going to buy. Find the probability that she will buy it. Buy it means, what is she going to buy? Good ones she's going to buy. So find the probability of the good ones he's saying in the first one. Second one, she will not buy it. Find the probability of the defective ones is what they are saying in here. Okay, so first, the probability of the event is going to be, how many good pens do I have? So it is actually favorable upon total. Number of good pens is equal to total minus defective. Total minus defective, that goes as 144 minus 20, that is equal to 4 here, and 14 minus 2 will be 124. So it is, good pens are 124 divided by the total number of pens, that is 144. So reduce it down further, times 2 table. 2 6s are 2s are, 7s are 2s are, okay, 2 3s are 1s are, 2 3s are 6s are. So it is 31 upon 36 is the probability. Now she will not buy, that means it is talking about the defective probability in here. So what is the defective probability? Again, we have two ways to calculate this. Either I can go with probability of the event plus the probability of the not event is equal to 1. So it is 31 upon 36 plus the probability of the not event is equal to 1. So it goes towards the other side. The probability of the not event becomes 1 minus 31 upon 36, which is 36 minus 31 upon 36, that is equal to 5 upon 36 is what you get. Likewise, we have to do this one now. This is one method. Okay, the other method that I have is defective pens. I'm supposed to pick up and I have to write it down. So the probability of the event for defective pens is, how many defective do I have? 20 divided by the total number of pens is 144. Let's start reducing by 2 times table. 2 10s are, 2 7s are, 2s are, 2 5s are it goes, 2 3s are, and 6 are. So it is 5 upon 36 this way as well. Now the last question that we have here is tossing 1 rupee coin, okay, 3 times. Hanif wins if 3 outcomes are same. What is the probability that Hanif loses? That means the same coin, there are two conditions. You can have the same coin tossed 3 times, or what you can do is you can take 3 different coins and toss it 1 time. Okay, but what is the probability he wins if same, if three outcomes are same, so if he gets heads, 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 he's going to win, or tails, 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 he's going to win. But rest of the others, he's going to lose. So he's saying Hanif wins, find the probability that he loses. So first of all, what is the total number of outcomes? We do not know. To find the total outcomes, what is the formula we are going to use? We have told you for a coin it is 2, so you need to multiply it twice or thrice. If it is 2 throws, multiply it by 2 times the same number. If it is 3 throws, multiply it thrice. So this becomes 2 twos 4, 4 twos 8. It becomes 8 in here. Okay, so total outcomes are 8. Now what are those outcomes? Let's list down. 1 and 2 we have already listed. Then heads, heads, tails can be 1. Then the tails can be here, head, tails, head, or the tail can be in the first one, tail, head, head. Okay, this is done. Then it's only one tail here, but tails can come twice also, no? Tails, tails, head, or tail, head, tail, or head, tail, tail. These are the options that you can get. 1, 2, 3, 4, 5, 6, 7, 8. 8 options. So Hanif loses. He loses for these total, right? So the probability that Hanif loses is equal to, loses probability is 3 plus 3, 6, upon the total, that is 8. So reduce it down, it becomes 3 upon 4 is the probability that he loses. That's the end of the chapter from the textbook. Next video will be the not the exemplar, but the R.D. Sharma questions for probability.